Hello, everyone. Good morning. Thanks for joining another meetup. This one is 31, regular ngParty meetup. Let's start. Before we're going to start, I would like to thank our main supporter, which is LiveSport. They truly know what supporting open source means and local communities. And hopefully, we'll see you soon at their place having offline meetup. But it will depend on how the COVID situation develops. But yeah, again, thanks a lot, LiveSport. It's great to have you. And let's start with the intro. So for those of you that are here for the first time, what is ngParty? You may think it's Angular meetup because of ng. In reality, that ng stands for next generation. So ngParty is a next generation development community group mainly focused on JavaScript. And it was established in 2015 in Prague, Czech Republic, and founded by myself. My name is Martin Hochel, and by Mario and William. So that's about us. Regarding the meetup setup for this year, it's going to be online only, unfortunately, because of the COVID situation. Every meetup should take up to 1 hour, and we changed the content or the focus to have only one special guest for every meetup to deliver more technical and deep dive talks per one particular topic. And if you want to follow us and also help us spread the word, we are at various social media, so check those out. We have also our Slack channel. If you want to discuss some topics in more depth, feel free to join. We also do open source. And if you want to watch like previous online meetups, we have a YouTube channel. So make sure to subscribe and check it out. Last but not least, we are always looking for speakers. So if you have anything interesting to share with the world or with the local community, please reach out. All right. What's today's agenda? We have 3 things on our plate. So first going to be the traditional lightning talk, TLDR, by the ngParty team. Then we're going to have our special guest, Mark Dalgleish, talking about Zero-runtime CSS-in-TypeScript vanilla extract. This is super exciting topic. I'm really glad we have Mark here. And after his talk, we're going to have a Q&A session. Regarding Q&A, what's the format? So please feel free to ask anything via the stream chat. And later on, after Mark's talk, I'm going to share a link so you'll be able to join us live in the studio so we can have like more human interaction, right? So don't be shy. Let's join us and ask your questions. And with that said, let's start with the lightning talk. So TLDR. All right, so what happened in the web ecosystem recently? So there was a release of TypeScript 4.3 RC. It brings another set of very nice features, mainly for object-oriented programming. Like if you are using classes heavily, there are some very nifty features included, but also much more. So make sure to check out the article regarding the release. Next one, recently, actually yesterday, Jest 27 was released. Jest is a excellent testing framework, which can be used with any kind of technology if you are using Angular, Vue.js, React, and whatnot. So yeah, it was quite a long time since Jest 26 came out, and it's good to see another progress by the Jest team. So check it out. Angular v12 was released as well, so another big milestone for Angular community. There are, again, various features. Most important one, in my opinion, is that Ivy renderer is now a default. So you should get much faster rendering times. Another release, Parcel v2 was released, and with a big surprise, they rebuilt the compiler with Rust, meaning it's now 10 times faster. So very interesting. Very interesting things are happening in the build systems area. So check it out as well. Another big release, StackBlitz, that's an online editor. They recently announced the web containers. And this is truly like mind-blowing. What they basically did is you can run Node.js in your browser via WebAssembly and like native platform features shipped into the browsers. So yeah, I'm not gonna go into details. Make sure to check it. Like, this is the most groundbreaking announcement I've seen yet this year, and it's super exciting. So check it out. Regarding articles, NX released a very interesting blog post. If you're not familiar with NX, it's a fantastic toolkit for working with monorepos, and I'm using that a lot at work, also at previous companies. And people always ask me, like, what does it do, and so on and so forth. And this article very nicely explains all these feature set via diagrams. So it's very easy to grok. So check it out as well. Next one, get ready for ESM everywhere. That's another interesting article, meaning like recently Node 14 was propagated to LTS since April, meaning ECMAScript modules are now everywhere. So not just in the browser, but also in a Node.js. So yeah, meaning you can start using it everywhere and be familiar with just one standard way how to use modules in JavaScript, which is great. Also, last week there was Google I/O, and folks from Google prepared very nice recap regarding 8 things that are important or that happened during this event. It's like 4 minutes. Check it out. It's great. Another interesting thing regarding tooling, Google Docs recently announced that they will be switching to Canvas for rendering, which is indeed very interesting for various performance reasons and stuff like that. I'm really looking forward how this is going to work. I mean, regarding accessibility and things like that, Canvas might be tricky, but let's see how it goes. And last but not least, regarding open source software, like Babel recently published an article that they are running out of funding. And I don't know about you, but I'm using Babel almost every day. Probably you as well. You might not know it. So what would be a nice thing to do, just maybe reach out to your leadership of your company and try to support Babel with some small amounts of funding, because it's a really crucial part of everyone working on the web and with the JavaScript. And yeah, let's help them out. And with that said, that's about the news. And one other announcement regarding local online events. There is going to be a front-end conference this Saturday. Our friends from frontendist.cz are organizing it. It's a whole day event. Make sure to check it out. And we have also 3 free tickets for you. So if you're interested, ping us at one of our social media platforms, and we will give you the discounts. And that's the end of the lightning talk. And with that said, I would like to welcome Mark. Hey, Mark, how are you doing?
I'm good. Thank you for having me.
Pleasure is on our side. Thanks for taking the time. And yeah, the stage is all yours. So
thank you.
Bring it on.
Now to just share my screen. So you can see that okay?
Yes.
Awesome. We're good.
It's live. So
yep. Cool. Thank you. So, all right. So as you can see here, I've gone straight into demo land. So what I wanted to do today is show you rather than tell you as much as possible. And I'm going to do that by showing you like a live project working with Vanilla Extract. But before I get into that, obviously I need to give you a quick intro. What is Vanilla Extract? And maybe first of all, who am I? So for those of you who don't know me, my name is Mark Dalgleish and I'm from Melbourne, Australia. I work at a company called Seek, and I'm probably most well known for my work as the co-creator of CSS modules. Now, CSS modules probably doesn't need much of an introduction, but you know, it was a really big step forward for the community in terms of making regular CSS more maintainable at scale by locally scoping your styles and hash and class names and forcing you to be explicit about the relationships between your styles and your UI code, like if you're using a library like React that we use at Seek, if you wanted to use a class from a style sheet, you had to explicitly import that style. And so, for us, that was like a huge step forward in terms of how do we make CSS more maintainable without having to, manually prefix all of our classes, which is what we were doing before using the BEM syntax. And at Seek, we, over the years, built up our component system on top of CSS modules and scaled it up that way. And even though we invested so heavily in CSS modules, we were always, I personally was always a huge fan of CSS in JS. We were compiling from less into CSS modules via Webpack. And I was watching the CSS and JS space with a lot of jealousy, in the sense that I really liked the fact that there was a unified language within a single project when you adopted that technique. So you didn't have to, as I did, you didn't have to jump between these different paradigms in terms of the language you had to use. And I was always very interested in that. But there was always this trade-off with CSS and JS that you have to adopt a whole different way of running CSS in production, that you would ship, JavaScript that would execute to generate styles in the user's browser. And I was very interested in this idea of, how do we bridge the two worlds together and say, how do we get the performance characteristics and the development experience that you expect with CSS modules, but you still get the unified language benefits that you get from your regular CSS and JS approaches. And so there's a whole bunch of history behind this. I won't go into this today because, again, I want to show rather than tell. But basically, that's the backstory behind Vanilla Extract. Now, Vanilla Extract is a library that I've built at Seek along with Matt Jones and Michael Taranto, and it's open source. You can use it today, and it's very much the culmination of a lot of the thinking in this space around how do we take regular CSS files and regular CSS in production, but how do we make it as scalable and as maintainable as possible? So the idea here is that you effectively are using, we're going all in on TypeScript here. The idea is that you're using TypeScript effectively as your preprocessor. A lot of people not so sure about that term because it seems to undersell what's so good about Vanilla Extract. But as you'll see, this, in my mind, this is like a next generation of pre-processing, because it's not just adding some missing features to CSS, but it's about making it really, really scalable. Okay, so I could go further and scroll down through the docs and look at all the the sales pitch, but instead, what I'm going to do is show you a live running application and start to build up using the features that we have available in Vanilla Extract. As you can see here, the application's not very attractive. It's an app component. So this is using React. Before I go further, actually, I should stress that the library is not at all coupled to React, even though I'm using React today. Just like CSS modules, it'll work with anywhere that you can render with JavaScript, whatever framework or library you happen to use, as long as you can hook it up to a bundler that can understand it. You'll be able to use Vanilla Extract. So at the moment we have integrations for Webpack, but also for ESBuild and Vite as well. So and there could be more on the way. It's pretty easy for us to port to different systems. Today's setup, though, I'm going to be using React and Webpack. And you can see here I've got my app component. It's rendering a header. That header has got some like child text being passed in. If we drop into yes.
Sorry to interrupt. Can we increase the font size in the editor?
Sure thing.
Much better. Yes. Perfect.
Cool.
Sorry about that.
No worries. So we've got our header component here. Let's change the. I might make the editor a little wider now. There we go. So we've got our header component here, and it's rendering an H1 with passing the children in. And there's the types there, so you can see it's written in TypeScript as well. Okay, so what we're going to do is start adding some styles to this very beautiful application. Now, the first thing to note here is that I'm going to create a style sheet. So it's in terms of developer ergonomics, it's very similar to CSS modules because we're trying to embrace the fact that you're creating static style sheets and that there is a bridge here, that there is code that we're going to execute at build time to generate our styles. This code will not run in production. So we're going to create a new file here. It's scoped to our component. So as a naming convention, we're going to call it header.css.ts. So that's the key point here, is that we've got this naming convention on the file extension to say .css.ts. This is so that the bundler is able to detect that this is a vanilla extract file. So if I quickly jump over to a Webpack config, you can see here we're pulling in the vanilla extract Webpack plugin. That's wired up down here. There's also a Babel plugin that you need to use as well. And so this Webpack plugin looks out for this file extension, and it knows to execute this code ahead of time during the build process. So here's our style sheet. Now, I call it a style sheet. It's a TypeScript file. I'm going to import something here. I'm going to import style from vanilla extract /CSS. Okay, and so we have our style function. Now I'm going to create a class and export it. I'm going to say export const. I'll say the root class is style. You pass it an object here, and we can do something like, let's say font size of 42 pixels. We'll say padding of 32 pixels. We'll give it a background of aqua and color of blue. Some random things. Okay, so if we jump over to our component now, what we're going to do is very much like CSS modules. We're going to do import star as styles from this new style sheet we've created, header.css. Now, even though it says header.css, that's literally just because you don't put .ts at the end of your inputs. It is still just a regular TS file. Why that's really cool is that, you know, TypeScript can make perfect sense out of this code right now. It knows that there's a TypeScript file I'm importing. It has some named exports, or in this case, one named export. So that means if I come down here to my h1 tag and I say that I want to have a class name, I can reference it here and say I want, let's pluralize that, styles. And you can see here it's got auto completion of root. I hit save. My styles have come through here. And yeah, it looks beautiful. It looks slightly better than before. The cool thing here is that because I'm using TypeScript, right? Like if I have a typo here, you know, it's telling me it doesn't exist. And I didn't. What's cool is that I didn't have to like you might have to do with something like CSS modules. I didn't have to run a separate task to generate a TypeScript declaration file or anything like that. Like I'm importing a TypeScript file. TypeScript knows what's going on. I don't need to generate anything. But you know, if you look at this, it looks very much like a regular CSS file. Effectively, I've created a class. If I come over here and I view page source of what's being built, I scroll across, you'll see here there's a main.css file that's come out, and it's going to look very much like what I wrote. So this looks like, again, if you've used CSS modules, this is kind of like CSS modules in TypeScript, effectively, because I've got my automatic, you know, BEM style prefixing. I've got header because that's the name of the file. We've got underscore root. The Babel plugin is able to pick up the fact that I've called it root here, and it puts that in the name. And then you'll see there's a couple of underscores, and then there's a hash. So the hash is what goes to production. This is just for debugging and development. So it means you get nice minified styles in prod. You don't need to ship all these names to your users. All right, cool. So what I'm going to do now is obviously build up a little bit more, because this is very detached from what a real application looks like. The first thing I'm going to do is start to make it a bit more realistic in terms of wiring up to a component, because you can see here I've got my header component. I'm rendering the root class, and that's it. But in reality, you might have a prop or two that decide which styles you're going to render. So what I'm going to do is introduce this new API, another API here called style variants. And what style variants does, as you'll see, is it lets you kind of create little namespaces within the style sheet that let you do lookups within those collections of variants. So for example, I might want to have multiple backgrounds and multiple colors to choose from. So what does that look like? So I'm going to say export const background equals style variants. And the way it works here is that you pass an object of keys and values, the values being style objects. So we're going to say blue is, I'm going to keep it simple here, background color of blue. And let's add a few more. So we'll say we got blue, aqua, oh, let's fix that, blue, aqua, pink, And we'll do the same for foreground color. So we'll just call that color. Change these to color. Okay. Delete these colors here. Okay, so if our colors vanish from our demo, we're going to jump over here and say, first of all, let's add it to our types. This is where I think it's really interesting that your styles are written in TypeScript, because you get to effectively like export or infer types from the style sheet itself. And this is where style variants is very useful. So if I'm going to have I'm going to add my background prop here. I'm going to say that the type here is key of type of styles dot background. So I'm actually going to use the style variants object as the source of truth for this prop type. So you can see here that the type is a record of blue or aqua or pink or red to string. So that those keys are now the background type. So you can see background is those keys that came from my style sheet. I'll do the same for color here. So now I've got background and color types coming through. Now I actually need to wire it up to the element itself. So let's use these new props we've introduced, background and color. They're unused at the moment. What we're going to do is pull in class names. Auto import going to work for me. Yep, there we go. And we're going to say that we want to apply the background style. So we say styles.background. But the cool thing is that this is an object where I can look up by key the background prop that I've got coming in. And likewise, I can do the same for the foreground color. Come on, prettier. There we go. So I'll make that color as well. What's really neat here is that without having to do any prefixing or mapping or anything, I've got little like subsets of styles coming out of my style sheet. I've got my background object, my color object, and I'm using the prop coming in to look it up. Already, you can see that my app.tsx has a type error. This is perfect because I've said that these are not optional. You have to provide these, right? So if I go over to my app component, header is going to say, well, you got to give me a background color or background here. And there we go. Like TypeScript is already helping me out here. I've got my colors provided here. Let's go with pink for the background, and for the foreground color, we'll choose blue, whatever. Cool. And so that's all coming through. This is all type checked, of course. So if I've got a typo there and a typo here, it's going to tell me they don't exist. And also, like the source of truth, again, is in terms of the types, is coming from the style sheet itself. So if you can see here, if I've got my app here, I've set the background to pink. If I go to my style sheet and I go to my backgrounds, if I comment out the pink line, straight away I'm getting a type error over here, because that style sheet itself is the source of truth for what values are available. So if I bring that back, TypeScript's happy, everything's working. Again, if I view page source and I look at main CSS, now that this is sort of the trade-off with this approach, right? Is that everything I'm specifying here gets built ahead of time and it's all available, just like when you work with regular CSS. So all of these colors that I've specified, they're all in my final style sheet. That gets sent to the user. So you can see here, I've got my header root class, I've got all my backgrounds, I've got all my colors as well. Okay, so I guess the next thing I want to do is show you, what does this look like if I start to use theming? So one of the big selling points of Vanilla Extract is it's not just type safety in terms of the classes and the relationships, just like CSS modules, the relationships between your classes and the UI code that consumes it, but it's also type safe CSS variables. And I'll show you what that looks like. So what I'm going to do is I'm going to create a new file here, and I can call it theme.css.ts. Again, this naming convention is important. So I'm going to export const vars, my CSS variables. And that comes from create global theme. There's different, so quick side note here, there's lots of different ways you can do theming in regular CSS, which is to say your app might have a single theme. You might have multiple themes. You might want to bundle split your themes if it's like a white label app and each user only gets a single theme. There's all sorts of different ways you want to do theming in reality. Vanilla Extract handles all of them. But to keep things simple, I'm just going to show you probably the most common. I did a Twitter poll, and this is by far the most common theming system that people have, which is just one theme for their whole app. just as a way to have shared design tokens through their styles. So here we're going to create a global theme. Global meaning, you don't have to put a class onto an element to get the theme variables. You have to attach it to a selector though. So the most common one is :root. So just the whole application has access to these themes, to these tokens. And what I'm going to do now is pass an object of tokens here. So I'm going to say, let's have some colors, for example. We'll keep it simple. We'll go with red, blue, same as we had before. This is our palette, and pink. We might also want to have a space scale. So say none is 0. Variables have to be strings, just to ensure that you use units, because CSS variables, we can't infer the units from them. We'll say small is 4 pixels, medium 8. This is very contrived, not a realistic palette at all. Large is, let's just double it each time, and large is 32. What else did I do? So I had font size and padding. So let's go with the font size. Font size here, we'll say medium is 16 pixels, large is 24, and maybe X large is, what did I say? It was 42 something. Okay, so there are our variables. I'm not using them anywhere yet. So what I'm going to do is jump over to my header style sheet, and I'm going to start replacing these with my CSS variables that I just defined. So I'm going to let auto import do its magic here. Vars dot font size dot, and there's everything I just defined before. Let's go with X large, I think it was. Padding, same deal. Vars dot space dot X large, I can't remember. Same one here. So in fact, the variables have the same name, so it makes it pretty easy. I can just do this. Vars.color. There we go. So all of our colors that we set up before are now wired up to our variables. Everything should still work the same. But if I open DevTools here, let's have a look at what's being used here. You can see that everything's a CSS variable, right? Color is var color blue. You see that background color is color pink and so on. What's cool here is that it's got the same prefixing and hashing treatment that you get with your classes, in the sense that in development you get the nice readable names. Because I passed this object right in my theme, it's able to add these as human readable prefixes on all the variables. So color red, color pink, so on, or blue. But you'll see there's the hash there at the end, and that hash is the only thing that goes to your users when you do a production build. The other thing that's worth calling out here that you might start noticing here is that all of the hashes are scoped because this happens at build time. We're able to scope the hashes to your files, meaning that the hash is the same for everything that came out of a single file, but with just a counter being incremented at the end. Why that's worth noting is that typically the hashing algorithms give you basically a unique hash for everything, which doesn't compress anywhere near as well as this technique, where if you have lots of classes coming out of a single file, you think of something like gzip, it's gonna love you for it, because you've just got the repetition of the same hash effectively. This 7GUBAW, right? That's repeated over and over again. And the more things I have coming out of a single file, which is typical in a design system, right, where you've got a lot of variables, maybe a lot of reusable classes and so on that you've defined in a central place, you're going to get rewarded in terms of compression at runtime with that. Lots of repetition in that. So yeah, again, if you I like doing this, you go through and you just look from a user's perspective, regular CSS file coming out. And this is what we've created. So we were the ones that wrote, this selector. We want our variables to go on root. Well, that's what's come out in the style sheet. Here are all our nice debuggable CSS variables coming out. And otherwise, the CSS looks like what we saw before. We've got our header, root, and the backgrounds, our foregrounds. But again, everything's pointing at these CSS variables. Yeah, so it's just plain old CSS like you might have written by hand, but you get the the maintenance benefit of everything being written in TypeScript, everything's type safe. All the references, all the dependencies between the files are explicit, right? So that's in stark contrast. In stark contrast to what you normally do with CSS variables, where you write a piece of CSS that just assumes some variable exists, and then fingers crossed, there's no typo or no one like renamed it or whatever. Like it hopefully exists. In this system, there's no hope. You don't have to hope for anything. You have to import the thing you want to use, and if it's not there, you get type errors. Which is really good if you're working on a design system and you want to be able to refactor things and move things around, or potentially even export these variables for your consumers. So your consumers might want to have access to CSS variables. It's now potentially like a type-safe interface that you give to your consumers without having to change the runtime characteristics of CSS to achieve it. So again, the type safety is at work here. Like if I come here and I comment out my pink variable, you'll see that now I'm getting type errors over here that these variables don't exist on my theme. So very, very cool from a maintenance perspective. All right, now I could go further here. I mean, one thing that's worth noting is that these styles are obviously very simple, very contrived. Vanilla Extract, as the name might suggest, has been designed to be as close to the metal as possible, in the sense that you can effectively just write regular CSS when and if you need to. So in the sense, in this case, what it means is that if I want to, I could, for example, I could write a selector here. We have the selectors key. And then in here, I can write a selector that has to contain an ampersand, which is a reference to the current class name. But let's say I want, if I've got like a dark mode toggle that I put on the HTML tag, as a contrived example, I might want to have something else going on in here. And anything in here, as long as it's valid CSS, is good. So you can write selectors. That means you can do things like, you can say if it's nested inside of a div, I don't know, you can do sibling selected, whatever, anything you want to do. The full power of CSS is available to you. Use wisely, obviously. You've got media queries. You can say at media. In here, you can then say screen and min width of blah, blah, blah. And then in here, you can put your styles. These are obviously not realistic styles at all. You've got at supports as well. You might have seen before. You've got that support queries are available to you as well. All of it type checked. Yeah. You also have global styles. I'm not going to do that today, but you can, if you need to do a global selector, which is useful for things like CSS resets, that's also available to you. You've got things like keyframes, font face, and so on. So you have the full power of CSS, but these are obviously quite simple styles. Now, some of you may already be thinking this, but like this is not how I typically like to write CSS at scale, like every component having a style sheet with everything sort of manually being forwarded around. Especially when you get into the world of design systems where there's a lot of repetition, like I'm just pulling out variables that are from a defined palette. You can imagine if I wrote a whole application this way, again, if you look at the generated styles, right, there's going to be, I've done it once here. I've said the font size is this variable, but like if I use this all over the place and I've got style sheets for dozens and dozens of components, it means that my style sheet's just going to be repeating the same things over and over again. A popular approach for dealing with this that fits very well into component systems is the idea of utility first CSS. So if you've ever used Tailwind or something like that, or Tachyons, they're very much like a CSS first approach to this, but the concept is very much the same in the work that we do, where we try to reuse styles via reusable classes rather than necessarily just by variables in your style sheet. So, you can do that. You can solve this manually because this is just like code now. You can build up your own abstractions. But we've actually created this project that's a framework on top of Vanilla Extract called Sprinkles. And the idea is that you get to configure your own CSS utility. You kind of get to build your own CSS utility framework. It'll make more sense when I actually show you what it does. So we should start doing that. If I scroll down a little bit, you'll see kind of what it looks like to configure it. You can see here that we're creating some atomic styles. It's probably a bit small. I'll zoom in a bit. You just configure all the like low-level reusable values that you want to have available. So we're going to let's just start implementing it over here. Basically what we want to do is make it so that all of these things are available to us as reusable classes rather than having to write styles. So I'm going to create a new file here, and I'm going to call it, actually, let's put it in the theme itself. Keeps it simple. So we'll pull in this import here. So we've got create atomic styles and create atoms function. We'll get to this second one later. Let's grab this as a starting point, and we'll fill it in. We'll fill it in ourselves. Back to our app. Okay, so what this is doing is it's saying, we'll get back to this conditions part later, but we're defining our breakpoints. You can define different conditions. So it supports media queries, but it also supports support queries and selectors. So you can say that, you know, these styles can be affected based on the screen size. In this case is what we care about. And then in here is our config for what properties we want and values we want to have available. And the cool thing is you can pass in your CSS variables that you've defined up here. So what we're going to do is let's map all of these through. So we've got our color tokens here. Let's wire them up first. We'll say we want background color, not clip, color of vars.color. And we're going to wire that up to our foreground as well. And let's do the other ones while we're there. So we use padding. But when you do like atomic styles, you need to think about all the individual values first and foremost. So we'll do padding top of vars.space, and we'll do all directions. We'll say bottom, top, bottom, left, and right. Obviously, in practice, you're not going to want to apply top, bottom, left, right all the time. So the way you solve that is we have a shorthands option here that you can provide. So you can say that you want padding to be, it's auto-completing for me, which is nice. Top, bottom, left, and right. That's to say that if I ask for padding, I actually just set the value for all of these ones. And what's cool is you can even do things like you want padding X. This is something we have in our system. You might want to have left and right as padding X, for example. And padding Y, of course, will be the opposite of top and bottom. So there we've got some nice conveniences that we've configured on top. The other thing we had as well was our font size. We'll wire that up as well, vars.font size. And I think that's everything. Padding, colors, font size. Yeah, perfect. Now, here's where it gets interesting. So I'm not actually using it yet. It should be coming out because I've actually in the style sheet, even though I'm not using it yet because it's in the same file. You can see all of the, it's generated a bunch of reusable like atomic classes for us. You can see here that we've got our background colors, and see it's coming from the theme now, the theme file. We've got all of our background colors that's coming from our tokens, all of our foreground colors, all of our padding, top, bottom, left, right, and then our font size. Notice there's no concept here of padding X or padding because those are just at the JS level. They're just shorthands. They just map to these low-level ones. And then here's where the conditions come in. So you'll see that we've now got a media query for min width of 768. And now it's generated all the tokens, all the reusable classes for those. And then again for 1024, this is what we configured and all of these. So again, it's like you get to configure your own Tailwind or some equivalent, right? You get to decide which keys and values and which tokens and whatever, what variables they map to. You can do things like, everything here is mapped to a variable. For simple cases, you can do things like this. Like let's say I wanted to have some classes for like display, block, and flex, and none. I could go on, obviously. Flex direction of row, and notice like TypeScript's completing all this for me, which is really nice. We're using CSS type to get that. This is all type checked against CSS. So if I misspell, like if that's not valid CSS, I get a type error here as well, which is really nice. So you can go on and build up a whole set of like reusable tokens that in this case, I've said I want, values for each breakpoint, but that's completely up to you how you configure that. So then if we go over to here, you'll see everything that we're using here in our style sheet is now actually available in our reusable atoms, but we need to bind it to an atoms function. As you can see, we've got this unused function here. So we'll say export const atoms. You can name this whatever you want, but it's the atoms function. And you create an atoms function out of these out of these atomic styles objects. The reason we do it this way is because you might want to have different sets of them. So for example, in our system, not every class needs to be responsive. Like realistically, not everything changes across every breakpoint. And so we try to cut down on the amount of CSS by saying, well, this one, like in our system, our color isn't responsive. Background color isn't responsive because for the most part, we don't change colors across breakpoints. So we just cut out all of that extra noise. I'm keeping it simple here today, but you can pass more objects here if you want. The other thing I'm going to quickly do, we call out in the docs. It's really good idea to also export the type of atoms, which is to say, like if you ever need to say, I want to support all the background colors as a prop or all the colors as a prop, this just makes this available to you as well. So this is the interesting part. We've exported our atoms function from the style sheet here, and we're going to jump over to our header component. All of these styles now, we actually don't need to create a style sheet to get access to them. So what I'm going to do is just to keep it simple, I'm just going to replace one of them for now. Like if we jump back to our app, wrong tab, here we go. So let's get rid of the foreground color for a second. So it's gone back to being black text. So let's reintroduce that. So what we're going to do is we're going to call our atoms function here. And you'll see that we go to the top here, it's going to autocomplete, like these are the atoms that we configured before. So we're doing our foreground color, right? We'll say color is blue. Let's hard code it for now. Right, so, and that's all type checked. So if I have a typo here, it's going to tell me that's not one of your atoms that you've configured. Let's make it dynamic, of course. We've got this color unused here, so we can just pass that straight through in this case. This type now is wrong, right? Like in the sense that we're saying that its type comes from the style sheet, but like we're not even, sorry, wrong file. If we go here, like we're not using this one anymore. So if I delete that, I've now got a type error in my header because it's saying, your color, the type of styles.color, which no longer exists. This is where the atoms type comes in. So we've said, here's my atoms type. I can say that color is atoms color, like that's the type I'm using. So now everything's type checked okay. While we're here, let's do the same for background. So we'll say it's atoms and color, we call it. And let's pass this through here. So we'll say background color is background, delete this one. And we've also got if we go here, we've got our font size and our padding. So we can just inline that. So this styles.root, we can just inline that now. We can say font size is X large and padding is X large. So now that I've done that, you can see that this root class is no longer needed, right? Which means everything's still working correctly, which means this class names call is no longer needed. I've just got the one class, which means if we scroll up, you'll see we've got unused class names import, of course, but also we've got an unused style sheet. So we can just delete that. Which means our header.css.ts, we can get rid of it. We don't even need it anymore. But importantly, so we've just done a big refactor to use these reusable atoms. But architecturally, nothing has kind of changed in terms of what's running in the browser, because if I inspect the element, I've got a bunch of theme classes coming through here, like theme padding top, theme padding bottom, left, right, theme background color, and so on. Again, if I view page source, it's still the same as what we saw before, where we've got all these static styles in a regular style sheet. Even though I'm like at runtime, I'm toggling between different background colors, I'm toggling between different foreground colors. But we can go further than this as well. Closed Chrome. Bring that back. Bear with me. Wrong button. Of course, do it live on the air. Here we go.
No worries.
I got to
It
switch
happens all the time.
Here we go. Recently, it's supposed to warn me and not just quit. But there we go.
Yeah, exactly.
I set that up. Why are you doing that to me, Chrome? Okay, let's just manually bring that tab back. Trying to unclose the tab, and I close the entirety of Chrome. Okay, so we're back with our Webpack app. Yeah, so what I was going to say is we can take this further now, which is to say that like now we can do things like responsively change our foreground and background colors without having to have a runtime at all. So if we go over to our app, you'll see here we've got our header with the props coming through, pink and blue. I can change this to aqua and so on, and that's going to update live. So from a consumer standpoint of this component, like it almost feels like runtime CSS because I'm just changing these props and it just updates. But here I can, this is where the conditions come in. So I said that these props get the types from atoms. I can actually pass an object here that defines different conditions. In my case, I've said that the conditions are breakpoints. So I'm going to say mobile is pink. So that's the same as what we've got here. But what I can do is I can say that I want on tablet, as I've called it, you can call it whatever you want. I want it to switch to aqua. That means now if I resize my window, you'll see the color changes responsively. And I haven't had to change a style sheet. I'm just changing props on a component. Equally, the color, foreground color, I can do the same thing. So I've got blue here. Say blue here, but then really terrible. So the text goes red as well. So I can make everything responsive. I could do I could go on everything that I've configured in my atoms. It can just as easily do that. But I don't have to do it at the prop level, of course. Like if I go over to my header component, let's say I want my font size to change responsively. I can do that here. The other thing as well, that if you want, there's different ways that people write these responsive props or conditional values. You can actually configure a different syntax if you like, which is we call it responsive array is the option here. And what you do is you say, like, if I want to use a shorthand array syntax for this, you just got to tell us like which conditions in which order you want to use. So I'm going to say, as you can probably expect, in a mobile first fashion, I'm going to have mobile, then tablet, then desktop. So I've said I want to be able to support responsive arrays. Why that's cool is if I go over to my header component. So I said I was about to make the font size responsive. I can use the array syntax here now if I want. I can say font size is, let's say medium, and then X large. And there you go. So I've got a responsive text font size. Let's make that a little bigger. And I can do the same for the padding as well. And so yeah, that's written in like a mobile first fashion. So let's say I wanted it to change at desktop instead of tablet. I can chuck a gap in the middle with null if I want. Or I can put a different value here. I can say that's large and that's medium and so on. So you get to choose the syntax as well that you like. So now I've got 3 values here. As I go up, I go, there's 3 different breakpoints there with my array syntax. One gotcha though, I guess it's worth calling out with the array syntax, and what's why we don't push it as a default is even though this is what we've used at Seek historically, this one sort of scales awkwardly because let's say you wanted to introduce a new breakpoint in between these two, it's technically a breaking change. Whereas the object, you're sort of free to add new breakpoints in between and it's not an issue. Also, it means you avoid this awkwardness of having to pass nulls in the middle. If you just don't put the value on the object, then that's fine. You don't have to explicitly put these like gaps in there. So arguably objects are much better, but yeah, we support arrays as well if you want to. That's pretty much it. So the one final footnote I'm going to add, and I'm just going to do a quick Google for this. Here we go. Dessert box. So that what's really cool about what we're doing here with vanilla extract is that it's code that we eval at build time, which means that, as opposed to a lot of other solutions that try to do this via static analysis, they try to understand your code statically and then generate styles out of that. Because we're going for more of an eval at build time approach, it means that you can actually build up your own abstractions on top and calculate things and return big complex objects of whatever structure you want. Sprinkles is effectively using this technique of being able to iterate over a bunch of key value pairs and spit out a bunch of styles and an interface to those. It means you can come along and do things on top as well. So a great example of this is this open source library called DessertBox, which is designed to be built on top of what we've just seen, which is this sprinkles setup. The idea is that if you've got your atoms function, you can actually, if I scroll down a bit, you can actually create a box component from your atoms function. So it gives you a React component just in a single line that has the exact same interface that we just saw. So you can say box, padding left, background color, color, and have all the responsive props and everything you can see here, like box, padding, mobile, tablet, desktop. So this is very common in a design system. This is what we do at Seek. And it means that you can have a static CSS runtime, like just a static CSS file at runtime, but you get all the developer experience in a lot of ways of runtime CSS and JS, where you can render a component and have dynamic stuff coming in, changing out the props across different breakpoints. And this is also a good thing to give to your consumers of the design system is, here's low-level access to the reusable classes, but arguably it's a much nicer interface than something you get from something like Tailwind, where you've got all these global classes in a big long string you have to remember. This is much more type safe and integrates well with the component system, a type safe component system. So that's pretty much it in terms of a demo. So what I would say is, if you're interested, definitely do check it out, have a play with it. If you're interested in CSS at scale, but keeping it performant and keeping it type safe, I feel like we're sort of hitting a really nice sweet spot here. So if you agree with that, please do try it out. Reach out to me on Twitter and let me know how you go. I'd love to hear what you think about it in practice. Thank you so much for your time and attention tonight. I really appreciate it and hope you enjoyed that. Thank you.
Thanks a lot, Mark. This is really awesome. I'm gonna try it out today. All right, folks, and now it's time for your questions. So let me share with you the link so you are able to join us in the studio. No questions so far. People just say awesome stuff. Great stuff. Thanks, Mark. In the meantime, while we wait someone to join, I have some question, if I may. So, from the implementation perspective, that ahead of time compiler, what do you use under the hood? It's Babel or something else? How do you process?
So it's the way to think about it is it's designed to integrate with a bundler. So we'll go with Webpack for now. So if you think about the way you configure Webpack, right? You say, for a given file extension, run this loader, right? You'd say, if you see a CSS file, run it through this loader. If you see a TSX file or TS file, run it through this loader. If you see a SVG, whatever, on and on it goes. We're just hooking into that mechanism to say, if you see a .css.ts file, run it through its own separate process. And what we do then is we spin up a child compiler and we treat that style sheet as its own entry point to another compilation. And so we look at that style sheet. But the important thing is that so I'll finish that thread. So we compile that file treating that as the entry point. So we get back a JS bundle, right? Like Webpack's converted that into a string of JS. We can then eval that. The trick is that we need to wrap that string of JS in a little bit of environment in order to catch the styles that you register. So if you, from your perspective, you import a style function, right? That's like a side effect. Like you've thrown into the ether some styles, right, that you're registering. We just have to set up the environment to like catch those styles that you're registering. And so that means that when we eval all of that code, what we end up with at the end is everything you've exported, all the token, like all the class names, variable names, and so on. Anything that can be serialized to JSON effectively. And then what we do is, like all the styles that got generated, we generate virtual CSS files for those. And then everything that you exported from the file, that's what gets serialized into the final like JS file that goes into your like production bundle from a JS perspective. So it's going to be, practically speaking, it's almost as if you'd exported a bunch of like static objects with just class names on them. And so then otherwise it's sort of, it has all the characteristics of as if you'd done that by hand. Like you've added a bunch of CSS files to your build that are related to that file, and you've exported some objects with strings on them, you know. And so that maps really cleanly to other systems. Like there's not a whole lot of complexity there. The only reason we need Babel is, so for one thing, it adds the nicety of the debug IDs, automatic debug. You can manually provide debug IDs, but it just automates that for you. But the other important thing it does is it adds what we call internal, this is not a public concept, this is getting behind the scenes a little bit, but it adds what we call file scopes, which is to say like it puts some code at the top and bottom of each file so that we can tell which file it belongs to. That's really important so that you can reuse styles between different style sheets. Because if imagine I've got two style sheets and they each import the variables, they're effectively being evaled twice, like they're being generated twice, but we want to make sure that they belong to the one file it came from, like the vars theme.css.ts. We need to know that even though we're registering some more variables and some more styles again, potentially, we need to know, like, we've actually seen these before. It's come from the same file.
Yeah.
That's the other thing that we need as well.
Cool stuff. All right, we have some guests. Let's add them to the stream.
Hey, Mark.
Hey, Andre.
Can you hear me?
Yes.
Yeah, first of all, thank you for the talk, Mark, and thank you for joining us from the other part of the world. So I'm Andre Pfeiffer. I did an in-depth analysis of most CSS in JS solutions out there, actually we've chosen Treat for a project that we started at the beginning of this year, and so my first question would be, what besides the atomic CSS that is built on top of Vanilla Extract, are there any, or what exactly made you build Vanilla Extract to replace Treat? Is there anything missing from Treat, or is there anything that you found to be problematic?
Yeah, this is a good question. I didn't want to get bogged down in this early, but this is a good place to bring it up. So yeah, part of the history that I skipped over is that this isn't our first attempt at doing static CSS in JS or TypeScript. Treat was our first library in this space. So for all intents and purposes, Vanilla Extract is the continuation of the work we did on Treat. If the APIs weren't too different, it would have been Treat v3. It's just that it was different enough that we felt like it's better to draw that line in the sand and say, like, it would actually be too disruptive to think of it as the next version, because you kind of have to revisit everything. You also may want to migrate from one to the other. And so trying to run both versions of the same library would be a pain as well. The big difference is the core difference of what made us take a different approach was that Treat was designed to support theming, but it was designed to support theming for old browsers, most notably IE11, because it doesn't support CSS variables. So it had to use like Webpack magic instead, where effectively it will create styles multiple times, and it'll create a class for each theme. And then at runtime, you have to sort of dynamically swap between the, let's say your app has 3 themes, you have to dynamically swap between those 3 classes. And that's why there was also like, you'd have to use a React hook with treat to say use styles, because we had to say at runtime, we actually need to figure out which of the 3 classes, in this hypothetical example, which of them are you going to apply? So it means there's a couple of downsides to that. So one is it means it's a lot more coupled to the bundler. So treat was only for Webpack. Whereas vanilla extract, because it's a lot simpler, it's using CSS variables instead of what I just described. It means that we were able to, or Matt Jones did the work. Like he was able to migrate it to ES Build pretty quickly, and Vite as well, without much work. So that's one big plus. And it also means that I mentioned that there's a lot of sort of boilerplate, like plumbing required to look up the right theme at runtime. All of that goes away now as well, because it's just CSS now. And so that was part of the inspiration for the name Vanilla Extract. Was it feels a lot more like you're just using CSS. With treat, there's obviously a bit of magic going on, whereas here, I think it's a lot simpler and that makes me feel a lot better about the library. And so that means also from our perspective, it means it's a lot easier to maintain, because a lot of that complexity of how to deal with all these, all of this magic in the bundler, that's just gone now. So it makes it a lot simpler. So I would say that, if you're using treat, this is effectively, think of it as treat v3. It's something you should probably think about moving to. Obviously, if you need to support old browsers, then you might be stuck on treat until that changes for you. This is effectively the new treat. Yeah.
Yeah, gotcha. Thank you. Thank you, Mark. That makes sense. And also another question would be, what are your future plans for Vanilla Extract? Like, do you intend to make it as popular as CSS modules? What are your future goals?
Well, I mean, first of all, the popularity in and of itself is not really the goal. I think it's definitely a tougher sell than CSS modules, in that CSS modules was able to pull off a really clever trick where you look at it's just regular CSS files, and you could even use it with Sass or Less or whatever preprocessor. And so it meant that there's a whole audience of people that just want to work with CSS that were able to be very comfortable in that environment and feel like they're right at home, but they get all the benefits of maintainable, styles at scale and in a component system and all of that. This is going to, relative to that, obviously a bit more of a niche audience. It's people who like CSS, comfortable with CSS in terms of being able to write style sheets, but maybe want to have that type safety, want to be able to share code or tokens or whatever it is between the style sheet, the static style sheets, and their runtime code. It's definitely much more of a niche thing. What I'm trying to do ultimately is build the thing that I want to use. And I actually really like that feeling of just being in CSS. But I think with CSS modules, or just CSS in general, you hit a limit of maintainability at scale, like particularly when you bring in things like variables, where, compared to what you just saw, like plain CSS and global CSS variable names, it's obviously a lot less maintainable. You're just sort of, and it means that the tooling, you're effectively, if you want to get anywhere close to this, you're effectively going to have to build your own like linters and things. Whereas this just makes it feel like code. So, this is the system I want to use, and whether it gets world famous and millions of people using it, or a few hundred, like I'm happy either way. But yeah, I guess we'll see. In terms of plans, I don't know. I mean, one of the I'd say what we've focused on is building a platform that you can build your own abstractions on top of. So Sprinkles is a good example of something that, like, we don't have any privileged access. Like you could build your own equivalent or some alternative tool on top. So I'm interested to see what other abstractions people come up with. The other thing as well is I think there's still a lot more room for tooling to make it quick to build up a design system. Like Sprinkles is a good example of this, where sure, I can write style sheets, but in practice, like if I want to build a big complex system, it's maybe a little too low level and I want to have some things on top. So layout component library is something that I've been thinking about doing for a long time. I might be doing that on top of sprinkles. Yeah, so it's a bit vague. We're pivoting towards actually trying to roll this out through our design system to production. We're currently not in production with this yet, but hopefully not too much longer. We're actively working on that at the moment.
Gotcha. Thank you. Yeah, I'll be waiting for the release of V1 to review the library. So yeah.
Awesome.
Thank you. Thank you once again.
Thank you.
See you.
See ya.
See ya. All right, we have a couple of other questions in the chat. So let's start answering them. Mike was asking, usually it is a lot of things you are passing as prop to component. How to handle of this swarm of styles which are passed through props too? ? I'm not sure I understand the question.
Yeah, I'm not sure I understand. I mean, I could take a guess at what it means, but I'll probably be wrong. I mean, ultimately, in terms of architecture, like it's no different than regular CSS, right? Like you write a bunch of static rules up front. They may use CSS variables, right? That they might be dynamic at runtime as well. There's all sorts of things you can do. But in terms of how you architect your components and what gets passed where and what level of access you have publicly versus internally or whatever, like that's the same as any other system effectively. So if I understand correctly, that's probably more just a component architecture question, not really specific to vanilla extract. And to me, that's actually the benefit of adopting vanilla extract is there's that feeling of I'm not buying into some like philosophy really in terms of how to architect my app. It's pretty flexible. You can kind of do whatever you want with it. And so that's maybe good or bad, depending on your perspective. I like that feeling like, so for example, in our system, like some tools try to use CSS variables, but like abstract them away and have some system on top. In our case, like we give you low-level access to CSS variables. We even have a low-level create var function that just creates a single CSS variable, and you can set, use that and set that wherever you want. So you don't have to use the high-level theming system. You can drop right down to plain old CSS variables. And so, I mean, to the point of the question, it means that, like, yeah, again, vanilla extract it can kind of do whatever native CSS can do, and so architecturally, anything's on the table. It's however you want to manage that's up to you.
Yeah, sounds good. Another question, hopefully this is more understandable. Can the CSS bundles be split per route?
Yeah, so yeah, again, like what's cool about this approach is it's think of it as no different than using like CSS modules with Webpack, where you can do bundle splitting and so on. But I guess the trick with the challenge with CSS is it's a really challenging compilation target, most notably because like the order that rules appear in affects their the specificity or like the precedence of those rules. And so that means that unlike JS, where you can sort of pull out a bunch of like closures and just sort of shuffle them around like a deck of cards and it'll still work correctly, you cannot do that with CSS. Like if you split out some CSS and load it in a different order, potentially, the styles end up clashing in like resolving in a way that was different than what you saw in development or with a different, if it optimized it differently. What I would say is that, to me, sprinkles or that approach of utility first CSS is a good answer to this, where you actually want to cut down on the amount of CSS you have overall anyway, where the core 80+% of styles in your app are just the same classes repeated over and over again. And then you only need, so this is how we build Braid, right? Like we have these core reusable classes repeated some complex components or, the odd case where you're doing something very specific, you just have a little style sheet just to do that one thing. And then there's less of an issue about styles clashing, whatever, because you've got your core styles at the top that are sort of designed to be overridden effectively. They get loaded first. And then you have these style sheets that are sort of littered around just to do these one-off styles. And all of that works really well with Webpack and bundle splitting and everything, that what you would typically do with CSS modules.
Yep. Awesome. Another one. Is there an easy way to integrate this tool with existing CSS frameworks like Tailwind, Bootstrap, or Foundation?
I'm less sure about the Bootstrap or Foundation question, but what I would say is, like on the Tailwind front, I don't know if it's quite getting at what you're asking, but the Vanilla Extract website actually is using the Tailwind color palette, and we're importing that from npm because they expose it as JavaScript objects.
Yep.
And so inside of our like sprinkles config, we're literally importing from Tailwind and setting the colors on CSS variables. So basically, it'll integrate with anything JavaScript in that sense. Yeah, I'm not so sure about the Bootstrap or Foundation style, but it integrates well with anything that can run in JavaScript. So another good example of this is like Polished is a really good library for manipulating styles or generating scales, as well as another good thing it can do in this case. And so it integrates with all that sort of stuff. The other thing as well is it's I guess another point worth making is that one of the reasons I'm a big fan of static CSS is that because there's no runtime cost, it means that you can run it alongside other approaches without normally it would be a bad idea to, like, if I'm in production, I'm running style components and emotion at the same time. It's like I'm taking this double hit. The beauty of doing static CSS is you can couple it with, you could use this with Tailwind and with Bootstrap, whatever. You can just combine static approaches together, and you're not going to have a runtime hit. You may have extra styles or something, but the runtime, there's no hit there.
Sounds good. All right, we have 4 more questions, and I would say we'll wrap it up afterwards. So the next one is from Marco. If we have a library that has box, stack, text, etc., that's built on top of an internal atoms, how would the consumer extend or override that atom function, like theme provider?
I guess it depends. So, I mean, I'm just trying to fully understand the question. So, I mean, I'm thinking about this from the perspective of an in-house component library, right? Where consumers aren't really meant to extend and override things. So that's the architecture I'm used to dealing with. Like a consumer might want to access the variables and access the reusable tokens and so on, or reusable classes. If they want to write custom things, then they just go ahead and write custom things on top. Like they don't need to integrate with it in any way. Like the box component can accept a class name and you can pass custom styles. I'm not sure if this is what the question is getting at, but if I was building an open source component library that was using Vanilla Extract and I wanted it to be customizable, what I would probably do is have like effectively a config file for my library that's a CSS-TS file, and make it that, like, as part of this framework or library or whatever it is, you need to create a Vanilla Extract file that configures things and exports them, and then that gets passed in as an argument to he says like a theme provider, like, yeah, maybe you pass it in to a provider or something. It depends what you're trying to achieve, but I would say that if you want consumers to configure the static styles, then you would naturally have to expose the fact that it's using Vanilla Extract. You couldn't abstract that away. Like they have to write their own static styles as well.
Yeah. Awesome. So another one is, can the CSS bundle name be content hashed for caching purposes? Yeah.
It follows the same rules as anything else with Webpack. Yep.
Yeah. Sounds good. Another one, is it effective way to write CSS, especially from the perspective of final data size, when you have big project with many colors, padding, margin sizes, custom boxes, and wrappers, and so on?
Yeah, so to me, this is why sprinkles is something that I show very much, like, soon after introducing vanilla extract. I show like in reality, you don't want to just have style sheet after style sheet for every component in your app. You want to have like a lot of reuse. And I think utility first CSS is a really great answer to this problem, because I mean, the vanilla extract site itself is built this way. We've got lots of colors coming in from Tailwind. That we didn't pull in the full Tailwind color palette, but we pulled in the colors that we use. I didn't demo this, but what's cool about having custom conditions in Sprinkles is that you can set up light mode, dark mode as a condition. That's what we did on the vanilla extract side. So you can say like the background of this element in light mode, it's this color, and in dark mode, it's this color. And that's all referencing the CSS variables that, again, came from Tailwind as well, which is, I love how it all comes together. And so we have, all the padding and margin values and display and, flex direction and so on. And across lots of breakpoints and colors across light mode and dark mode. And yet once everything's, G-zipped, you end up with like 5K of CSS. It's like nothing. And that wouldn't be the case if we'd written more classic style sheets, right? Where it's just everything's got its own custom class everywhere. And so to me, that's the answer. Like I would say that utility first CSS is a really great architecture to adopt. And Sprinkles is a really good way to, I think it solves the biggest problem people have with you. It's definitely the biggest problem I had with utility CSS, which is like, okay, now you have to learn this like weird DSL with lots of shorthands, like PL means padding left, and MT is margin top and so on. Like a lot of people really don't like that. And I totally get it. I get the benefits of it. Like I totally buy into the philosophy of like why you want to do it. But as an API, I'm not a huge fan of that. And I think that what you saw here today is a really great counterexample of like, we can have the type safety, we can have more structured objects to define things across different breakpoints and so on. And we can have like hashed class names in production that are super short, super compressible. So it's like best of both worlds, right? You don't have to be a human compiler and write these strings of tiny classes. Like let the computer do that. We can write it in a much more readable way. And so then we can sort of have the best of both worlds, all the type safety, longhand, easy to read and so on. But to the question, like in terms of final data size, you can, depending on how much you follow those reusable classes, which hopefully is a lot to the point of the question, then you end up with a tiny bundle at the end, which is really, really nice.
Yeah, I totally agree. Really, really cool stuff. All right, last question. Really awesome stuff. Has your team at Seek started incorporating vanilla extract into Braid?
Yeah, so I touched on this before, but just to reiterate, like Braid in like the latest version of Braid that's out right now is still using Treat. We've had a long-lived branch that's using vanilla extract. We're currently in the process, like literally this week, of like working through it to make sure all the loose ends are tied up, everything's working. We've got we use Chromatic to do like screenshot diffs, which is really nice for this sort of work where if there are any visual bugs, like as we migrate from one system to another, it's helping us work through some of the minor issues. But it's looking pretty good. There's not a whole heap of work left. And so yeah, we should be in production with that hopefully within a month, if not 2, I would say.
Awesome. All right, and with that last question answered, I guess we are at the end. So thanks again, Mark, for coming. It was a real pleasure to have you. And for the rest of you folks, this was the last meetup before summer holidays. So we'll be back probably in September or October. So stay tuned. We will announce everything in advance. And yeah, have a wonderful summer. Stay safe whenever you are. And talk to you later. Have a good one, folks. Bye-bye.